So if you look at this problem here, it says Martin is planting a vegetable garden. Each row is 2 meters long. He wants to plant carrots along 3/4 of each row. How many meters of each row will he plant with carrots? And then they've got a strip diagram below it. Now look at the strip diagram and tell me why you think they show these 2 holes side by side there. Take a guess. Emma? Because there's 2 meters in the vegetable garden. The last class had a harder time finding that out. So there's 2 meters in the vegetable garden. So they had to show you this 2 meter. Now we have to show 3/4 of 2 meters. Why does it have 1/2 underneath these 2 meters? Why do you think they have little 1/2 tiles underneath these holes? Molly?
Because it equals 2/4 because there's 4 of them and 1/2 is 2/4.
1/2 and 2/4 are equivalent, but that's not why they have the 1/2 tiles there. Somebody else think about it. Look at the problem and tell me why you think they chose this model for this problem. Colson?
Because it'll be easier if you put them into 4 because they're together.
It'll be easier.
It'll be easier to put them together if they were into 4.
Okay. It's not so much that it's easier. What do you notice, Addison?
Because under each section where it says 1, there's 1/2 and 1/2. So it's like 1 whole.
1/2 and 1/2 is 1 whole, and there are 2 halves and a whole. Yes, but why do you think they split it up this way? Why didn't they do 7ths or 8ths or 10ths? Why did they pick these fraction tiles to shove underneath the 2 meter garden? Dean?
Because they're the closest in the 1/2, and they are one of the most manipulated to the most other fractions.
Well, it's a pretty common fraction to use,
Yeah.
but there's another reason. Yeah?
Because 1 whole can't make 3/4, so then they would split it apart. So
They had to show 3/4 of the 2 whole, and in order to do that, they had to take these 2 and split them up into 4 equal sections. Good. And when they did that, it created this strip diagram. If I wanted to show 3/4 of those 2 meters, how many 1/2 boxes would I shade in, Talia? 3. I can show 3/4 by shading in these 3 boxes. Now, what do those 3 yellow boxes represent? What are they? Somebody different. Tyler, what do these 3 boxes represent that I just colored in for Martin?
It represents 1 and 1/2.
Well, it is 1 and 1/2, but what is it?
3/2.
I'm looking for more than 1 and 1/2 or 3 halves. I'm looking for something else. Jack. Exactly. That's what he's trying to do. He's planting 3/4 of the row with carrots. These guys here are all carrots. And then he can put whatever he wants to at the end, strawberries or corn. But we have a 2 meter long row. I'm planting 3/4 of the 2 meters. So my answer is really easy to see because I have 1 hole shaded and then this extra 1/2. some of you guys are really good at getting to the 1 1/2, but you don't know what the different parts of it are. And when we start mixing up multiplying and dividing fractions, you need to be able to make sense of the word problem. Does this make sense?
Yes.
Okay, so the reason why they chose 1/2 tiles was because that's what they created when they split these 2 holes into 4 sections. This shows 3/4 of, remember that word of that I said was going to be important? 3/4 of 2 meters, and 3/4 of 2 meters is 1 1/2. I just realized I wrote this answer here on this row. That was wrong. That goes with this one. This one's showing 2 times 5 6, and it's going with this model. It's kind of hard to see, but my original copy showed 5 little pizza slices shaded in on each of these models. The circular models, guys, I think are really a lot easier, because if you take off one piece here, can I move it over here? Yeah. And after I move it here, what do I have left?
1 2/4. Yeah.
No, it's not 1 2/4.
Wait, 1 minute.
I have 1
And 2/3.
hole here, and I have 1 2 3 4. I have 1 4 6, but I'm going to simplify 4 6 by dividing it by 2. So after I divide by 2 and divide by 2,
1 2/3.
you get 1 2/3. Good. So I'm just cutting these in half. Do you understand? So the strip diagrams, usually in the book, it'll have an area where it's circled to show you what the answer is. But you have to be able to read the strip diagrams. Are we good on this? Okay. So flip over the page real quick, because we're going to go over the race car way to get the answer. You're going to have some questions on your homework tonight that are going to just be regular word problems where you're multiplying a fraction by a whole number. So if we want to just use the standard way of multiplying 4 times 2/3. Maybe I don't want to draw 4 circles and divide them up into 2/3 each. Or 4 rectangles and make 2/3 and add them all up together. This is the race car way to get you to the answer. Now, before I move on, can this 4 come to my fraction party? I can't let the 4 come to my fraction party unless I do what?
Put it in a fraction.
Mare? I have to dress him up like a fraction before he can come to my fraction party. He's not allowed in the door. So I'm going to put a 1 underneath him. Now can he come in? Uh-huh. So first things first is you have to dress him up like a fraction so we can play with the other fractions. Got it? Now this is the easy part. We're just going to run straight across the road and multiply. 4 times 2 is 8. 1 times 3 is 3. Can I say I'm done?
No, ice cream it.
Oh, no. His head's too big. I've got an improper fraction. I've got to make a proper fraction out of him. This is my fraction joke for the day. Y'all didn't get it. Okay, so if you want to ice cream him because it helps you keep it straight, that's fine. If you just want to divide, fine with me too. 3 will go into 8. How many times? 2 times. With how much left over? 2 2/3. Good, guys.